Hello, my name is Michael Wysession, and welcome to Lecture 36, the final lecture of our course on the geologic wonders of the world. Now, I hope that over the span of the past 35 lectures, I've given you the opportunity to gain an increased appreciation for the staggering diversity of geologic wonders, the curiosities, majestic sights, beautiful locations, bizarre structures, fascinating formations. I have to say that my command of the English language has really been put to the test here, coming up with enough different adjectives to describe everything that we have seen in this course. There have been mountains, sinkholes, glaciers, canyons, fjords, volcanoes, geysers, caves, crystals in caves, lava lakes, salt lakes, acid lakes, over 200 different locations of geologic wonders of so many different types in almost 120 different countries. And yet, I still feel that so many places had to be left out, places that just as easily could have been featured here. For example, I've come to the end of the course, yet I never got a chance to talk about two of the most beautiful places that I've ever visited, the southwest coast of Ireland and the western islands of Scotland. As I said at the beginning, what makes a place beautiful to you is just so very subjective. And likewise, I'm sure that there are places that you have been to that you would nominate for this course, and I apologize for not including them. However, my list of geologic wonders is not set in stone, so to speak, and I would love to see your nominations. All right. For this final lecture, I was trying to figure out how to best summarize the places I have talked about, but in a new way, and I decided to go in a very different direction. I will show you some of the remarkable geologic wonders that have been discovered on other planetary bodies in the solar system. You and I are not in a position to visit any of these locations, though people at places like NASA have not given up the dream of one day getting us there. Maybe your children's children might do it. However, using the remarkable robotic probes of NASA and other space agencies, we can now take virtual trips to many of these locations, and some of the things we have found here are truly incredible. While discussing these geologic marvels on other planets and their moons, this will also give me the opportunity to briefly return to some of the remarkable places here on Earth. Now, to the first order, you will find that much of the geology we see on Earth, sand dunes and glaciers and volcanoes, occurs elsewhere in the solar system, sometimes, commonly, in many different places. But they provide some unusual twists, as you will see. And there are some features that are nothing like anything we have seen here on Earth. So, let me show you some of the greatest geologic wonders out of this world. And let me start close to the sun and then move outward across the solar system. So let me start with Venus. We have seen remarkable lava flows around the Earth, in places like Hawaii, where the lava can flow for many tens of kilometers across the ground. On Venus, these lava flows can go for many hundreds of kilometers. It's the same material as lava on Earth, it's basalt. There's just lots of it. And the surface is so hot, it's 460 degrees Celsius, that the lava just flows easily. Venus is covered with volcanoes, hundreds of thousands of them, maybe even millions of volcanoes. Now, it's tough to figure this out because we can't actually see the surface. There are such thick clouds on Venus. By the way, they're not water. These clouds are made of sulfur dioxide and sulfuric acid aerosols that light can't penetrate through. But we combine satellite information both on elevation and on the roughness, the surface roughness of the ground, and that's how we can make these images. Now, the volcanoes here can be hundreds of kilometers wide, but they're actually remarkably flat. And I have to say, these stunning images have actually been vertically exaggerated by a factor of over 20. So the lava flows are actually remarkably flat here. Now, I've mentioned many places that have been described as being like hell, and Venus beats them all. I mean, on top of everything, sulfuric acid in the atmosphere and hot temperatures, the atmosphere is so thick, it's actually crushing. It's equivalent to being a kilometer underwater. Now, We've seen some places on Earth where the crust has been fractured into large numbers of parallel sets of faults that we call joints. Well, on Venus, there are whole expanses that are densely covered with these parallel fractures. They take many forms. Some are parallel like this, some are curved. They're given names like tesserae, coronae, and arachnids, which, as you might guess, have a sort of spidery look to them. Well, Venus's surface shows evidence of extreme stretching and compression. There is mantle convection under here. The whole rock of the mantle is flowing, but there are no tectonic plates. So the surface doesn't have anywhere to go. So it just gets repeatedly stretched and cracked and fractured. Volcanism is not active on Venus right now. However, Venus does appear to undergo a process of catastrophic global resurfacing every 300 to 500 million years or so. This happens when the heat in the mantle builds up to a critical level, and the surface will just continue to get stretched and compressed until that next resurfacing event. Next, I want to go to our nearest neighbor, the Moon. A few lectures ago, I showed the largest impact crater on Earth, the Vredefort Dome in South Africa, 300 kilometers across. Well, this is peanuts by planetary standards. The largest crater in the solar system is on the Moon, and it's the South Pole Aitken Basin. It's 8 times larger than the Vredefort Dome. In fact, it's over 2,500 kilometers in diameter and up to 13 kilometers deep. In fact, in some places, it's entirely removed the crust and the mantle is exposed. Unfortunately, it's on the far side of the Moon, so you can't ever see it directly. You need to use NASA images like this one. Now, this was due to a time of extreme violence in our solar system, known as the late heavy bombardment period. And this is a time when it seems as if the planets Jupiter and Saturn drifted into a 2-to-1 resonant orbit. And what this resonance means is for every 2 orbits that Jupiter does, Saturn makes 1. So Jupiter is moving on the inside and Saturn is on the outside here, and that resonance causes their orbits to be stretched out. Their elliptical orbits become very eccentric, and that destabilized the whole solar system, and things were flung outward. Neptune and Uranus were initially much closer in. They got flung to the farther parts of the solar system, and all sorts of large icy objects, sort of Pluto-like objects, got thrown into the inner solar system. So not only is there the South Pole Aitken Basin, but the Hellas Basin on Mars, which is 2,300 kilometers across. The Caloris Basin on Mercury, 1,600 kilometers. These are all about 4 billion years ago. Might have been something similar on the Earth, but geology has since erased whatever might have occurred here. Now, there might be one impact crater even larger than any of these. This is the North Pole Sea on Mars, and this is a region that's 10,000 kilometers across. And the whole crust is at a much lower elevation than the rest of the planet. In fact, this possible impact basin might also have been the location of a giant ocean at some point. Both of these are still very speculative. Now, Mars is a place of extreme geologic features that sets the record for all kinds of things that we've seen on Earth. It has a lot of similarities to Earth. There are deserts, there are glaciers, polar ice caps. It even has long-term climate change, enormous volcanoes and canyons. Let me give you some examples. We visited the big island of Hawaii, and Hawaii itself is a volcano 100 kilometers wide that rises 10 kilometers off the seafloor. That's pretty impressive, right? If we go and look at Olympus Mons on Mars, which is the largest single volcano in the solar system, we see something almost an order of magnitude larger. The central caldera here sits 27 kilometers above the mean surface level. That's 3 times the elevation of Mount Everest above sea level. The top sits 22 kilometers above the surrounding plains here. The caldera complex alone is 85 kilometers long and 60 kilometers wide, and 3 kilometers deep and 6 different craters in there. And the whole volcano is surrounded by a steep escarpment that's up to 6 kilometers tall. That's a 4-mile high cliff. This is really remarkable. And yet, this volcano isn't even the widest volcano on Mars. There is one wider, Alba Patera, which is 1,600 kilometers across. That's just staggering. 3 times larger in width than Olympus Mons. However, it's extremely flat. The total height is only about 3 kilometers. There's actually much less lava there that has flown out than at Olympus Mons. Hawaii is also the location of the largest hotspot on Earth, which we looked at as well. But because the Pacific plate that it sits on is moving rapidly westward, all that lava gets spread out over a long chain of islands and seamounts. Well, Mars also has the largest hotspot, and that's a whole region that's shown by red. This is a topography map that's known as the Tharsis Rise or the Tharsis Bulge. It contains Olympus Mons, that's the small little white-colored volcano in the upper left there, and several other large volcanoes. There's a trio there that are known as the Tharsis Mountains, and that's Arsia, Pavonis, and Escurius. The whole area of the Tharsis Rise sits about 7 kilometers above the surrounding plains. It's up to 30 million square kilometers. That's a quarter of the total surface of Mars. So Mars is really lopsided with this big lump of rock that has stuck out on one side there. It's likely the result of a giant hotspot, but because Mars doesn't have plates, all the volcanism all occurs in just one area. It doesn't get spread out. Now, on Earth, we looked at giant canyons, and the largest of the canyons are the ones that cut through the Himalayas. They can be 5 kilometers deep and extend for 240 kilometers. On Mars, we see the largest canyon in the solar system. That's this feature here, the Valles Marineris. Now, this is about 4,000 kilometers long, 200 kilometers across in places, and over 7 kilometers deep. In fact, it stretches 1/4 of the way around Mars's equator. It would stretch across the entire United States, from New York to Los Angeles. Now, we're not entirely sure how it forms. We think it has both tectonic and erosional origins. We think that it was initially formed during the bulging that made the Tharsis Rise. But because you often have rain, clouds and rain as air goes up mountains, air flowing from the east here would go up the side of the Tharsis Rise, the rain would come out, and that this valley was carved out to much greater level by rain flowing through. In fact, you can even see channels working their way all the way to that region of low elevation, the North Pole Sea on Mars. Now, Mars also has deserts, and it has some giant sand seas, and these are much farther to the north. One of the largest of these, the Olympia Undi, is one of these giant ergs, these sand seas. This covers 500,000 square kilometers. It's the same size as the Rub al Khali Desert in the Arabian Desert. The dunes here can be as much as 0.5 kilometer apart and rise up to 25 meters above the plain. Also in dry areas of the Earth, you sometimes find an unusual feature called a dust devil. And this is a sort of small mini vortex that kind of looks like a toy tornado. On the surface of Mars, these things are constantly zipping across the surface, responsible for all of the dust in the atmosphere. For example, if you look at this time-lapse picture taken, you can see some of these features, these dust devils zipping across. It sucks the dust up and actually pumps it up into the atmosphere. That's why Mars's atmosphere has a pink color. They also have turned out to be the most fortunate geologic wonders as far as the exploration of Mars has been concerned. There are 2 Mars rovers that have been operating on Mars since 2004, Spirit and Opportunity. It was initially expected that the rovers would stop working after just a few months, when the Martian dust would have settled and covered over their solar panels. Well, these dust devils keep zipping across them, and they act like windshield wiper blades. They keep clearing off the solar panels, and the rovers were able to operate for years. I talked about large dust storms in the Sahara and how sometimes dust storms could be so great that the dust could actually blow all the way over to the Americas. This is not uncommon. You also get enormous dust storms in the Gobi Desert in Mongolia and China that lifts up enough dust in the atmosphere that it travels around the globe. You can actually measure it falling in the middle of the continental United States. Dust storms on Earth are a huge hazard in many different places. And you can find a lot of parts of the world that are devastated by these storms. They've even shut down airports in Houston. But nothing on Earth compares with dust storms on Mars. These are the largest dust storms in the solar system. They cover the whole planet. What happens is a dust storm begins in one area and it heats the atmosphere. Sunlight hits the dust and that warms that part of the atmosphere. Well, when you have temperature differences in the atmosphere, that's what drives winds. So the strong winds pick up more dust, and the dust storm grows and grows, and after a couple of weeks, it can cover the entire planet with dust. Now, once the whole planet is dusty, there are no more variations in temperature, and the winds die down, and the dust slowly settles away. But this whole process can last for more than a month. Now, Mars also has the most complex ice caps in the solar system. Mars has a lot of ice. To begin with, the ground is filled with ice, like permafrost on Earth. And there are also huge glaciers all over that come down out of mountains and gullies. And these deposit rock at terminal moraines. We can see a lot of these places now around the surface, where areas that look like they were flat soil, we now realize are ice covered with a layer of dust. So we don't see the ice, but if you could remove the dust, this is what you would actually see. These are glaciers of ice flowing down across the surface of Mars, and we find these all over. The most unusual ice surface on Mars is actually the giant ice caps at the North and South poles, and these take a variety of different features. Now, the ice caps here have two components. There's a thick permanent water ice cap and a thin variable carbon dioxide ice cap, which is shown here. Carbon dioxide ice, you know as dry ice. These things are seasonal. They move back and forth between the two permanent ice caps, pole to pole, winter to summer, and back to winter again. About a quarter of the mass of the total atmosphere of Mars, which is mostly carbon dioxide, freezes out at the North Pole during the winter there. And then it goes back into the atmosphere during spring, and then freezes out at the South Pole during the North Pole summer. And this repeats over a Martian year. The solid water ice caps, and this is a computer generation of this, are fascinating. They're huge. This is larger than the size of Texas. And it has all of these repeating multiple layers that seem to be due to climate swings. Mars's axis of rotation is tilted 25 degrees, very similar to Earth, and that gives it seasons. But over time, that axis tilt changes from 0 degrees to more than 45 degrees. So there are huge long-term changes in the strength of the seasons, and that causes this layering. But there are also these large canyons that are cut up into the ice glacier, and we have no understanding of why this occurs. A very similar thing happens at the South Pole. I showed you some of the results of catastrophic floods on Earth, such as the flooding of the Black Sea 7,500 years ago. Well, Mars shows evidence of a period between 4 to 3 billion years ago when a vast amount of water carved away large portions of the land. And evidence is still seen all over the surface. For instance, these are the strange features called teardrop mesas. You can see this one here stretching behind a crater. That's often a nucleation point for these. But it's clear that a vast amount of water flowed across in this direction, shaping away the ground, carving it away, leaving these funny shapes. You also get evidence of enormous outwash of water. This is a giant stream delta, kind of like the Okavango Delta, the delta to nowhere. This water came down and is just dumped here on the surface, and of course, it's all dry now. There was a lot of water for a very short period of time. And it might be that some of this water came from these late heavy bombardment period impacts, icy rich planetoids actually bringing water to the planet. Or it could be water vapor coming out of volcanoes like Olympus Mons during an extremely active volcanic phase. In any case, this happened a long time ago, and the water is long since gone. Now, incidentally, on old surfaces like Mars, you see all kinds of craters. And I think that the most unusual crater is something called the pierced crater. So this is an impactor that split in two just as it landed, making a double crater. And in fact, you can see the wings on either side where material got ejected out from the collision. The second place in my mind for unusual craters actually goes to a small asteroid named Vesta. It's called the Snowman Craters. It's 3 craters in a row that look just like the outline of a snowman. The asteroids are a belt of rocky, icy objects that revolve around the sun in between the orbits of Mars and Jupiter. And Vesta, one of these asteroids, also has the tallest non-volcanic mountain anywhere in the solar system. It's 21 kilometers high. It's about the same height as Olympus Mons on Mars. It's found within a giant impact basin. And Vesta itself is only a little more than 500 kilometers in diameter, probably formed during the impact process as the central crater peak following that impact. But actually, I give another asteroid, Cleopatra, the award for the most strangely looking object in the solar system. It looks like a giant dog bone, 200 kilometers long, spinning in space. This is a set of time-lapse images, and you can see it rotating. It's a rubble heap. It formed from the loose connection of 2 smaller piles of rock and dust. And the best hypothesis is that when these 2 came, they hit each other obliquely, and they still are spinning around each other, but the weak gravity keeps them from pulling together into a single spherical object, and they just stay in this dog bone shape, spinning over every 5.5 hours. We got a very good look at what these strange rubble heap asteroids look like when the Japanese Hayabusa probe landed on the asteroid, the Itokawa, in 2005. And it also seems to be a binary asteroid, but it's remarkable to see these things up close. They really look like just a loose agglomeration of crushed rock and dust. Now, if we go farther out into the solar system, we get to the gas giants, Jupiter and Saturn. And the recent Cassini satellite mission has sent back amazing images of a variety of remarkable geologic features. 2 lectures ago, I showed you the auroras, the northern and southern lights. Well, these pale in comparison to the enormous auroras found near the poles of Jupiter and Saturn. These things can be hundreds of kilometers across, 250 kilometers above the planet, but they form by the same mechanism as auroras on Earth. They also have strange magnetic flux tubes that actually connect them with their moons, these little white areas there. For the auroras here, these magnetic tubes contain particles that have erupted from the surface of its moon Io and the other moons. And they flow down the flux tube to the surface of Jupiter here, adding to the colors of the aurora. Earth gets some enormous typhoons and hurricanes, such as the ones I talked about devastating the Ganges Delta. But for storms, nothing compares to the atmospheres of Jupiter and Saturn. Their fast rotation, Jupiter rotates once every 10 hours. For Saturn, it's 10.5 hours, cause the atmospheres to break up into many separate different bands. And where these bands intersect, they're enormous storm systems. The granddaddy of all of these, however, is the Great Red Spot. This is a 23,000 kilometer long hurricane that's been there for at least 180 years. It's not only the largest, it's the longest hurricane. Now, Venus might have the most volcanoes on it of any planetary object, but the title of the most volcanic place in the universe is Jupiter's moon Io. Io has hundreds of volcanoes erupting at any given time, like the little eruption we see on the edge there. Some of them are basaltic lava. Some of them are actually liquid sulfur. Io also has the hottest lavas anywhere in the solar system, over 1,500 degrees Celsius. The source for this is actually the tidal forces from Jupiter. It turns out that Io and two other large moons of Jupiter are trapped in a resonant orbit. Io, Europa, and Ganymede are locked in a 4-2-1 resonant orbit. So in other words, Io revolves around Jupiter 4 times for every 2 revolutions of Europa, for every 1 revolution of Ganymede. That stretches all of their orbits out to being very eccentric in their elliptical shape and keeps them warm internally. It generates the volcanism on Io. It also keeps Europa warm enough that it actually has a liquid saltwater ocean, maybe 150 kilometers thick, covered with a thin sheet of ice on top. The ice crust of Europa is the most interesting surface in the solar system. Pieces seem to break up and drift around over time. It looks like a giant jigsaw puzzle. The liquid saltwater ocean means that it's a likely candidate for life, even if it might only be single-celled. Now, sharing the same orbit as Jupiter are asteroids with the most unusual orbits, called Greeks and Trojans. Each of these set of objects is clustered together at unusually gravitationally stable locations that we call Lagrange points. They're located 60 degrees ahead of Jupiter and 60 degrees behind Jupiter. These two groups of asteroids will continuously orbit the Sun in the same orbit as Jupiter, but they will never mingle with each other. Now, it turns out that all of the large planets, Jupiter, Saturn, Uranus, and Neptune, have rings. But the rings of Saturn are by far the largest. To begin with, they look substantial, but they're really very sparse, very thin layers of small particles of rock and ice. Saturn not only has the largest rings, though, they're much larger than we ever thought. In this picture that with Cassini taking a picture of the Sun right behind Saturn, you can see that the rings actually extend to great distances. A whole new ring was discovered in 2009, the Phoebe ring, just inside the orbit of Saturn's moon Phoebe. And it extends 200 times out beyond the radius of Saturn. The polar regions on Earth are unusual with their ice caps, but for unusual features at the poles, nothing compares to Saturn. To begin with, at the South Pole is a vortex that's a giant eye of a hurricane. You can peer right down into the hurricane. This thing is 8,000 kilometers across. It's 2/3 the size of Earth, and it's ringed by towering clouds. The winds travel clockwise at speeds of more than 500 kilometers an hour. Another strange feature is up at the North Pole of Saturn. Here, the atmospheric flow takes the shape of a hexagon. And this was a huge puzzle for scientists until some people modeled it as a particular jet stream of gas moving at different speeds than the surrounding atmosphere. And this causes the flow to break up into 6 separate little eddies, little swirls. If the differences in speed were different, this could have been an octagon or a decagon or some other shape. Saturn also has some geologically fascinating moons. We looked previously at geysers on Earth, like at Yellowstone, some of which eject water almost 100 meters. It's a football field high. Well, Saturn's moon Enceladus has ice geysers that eject ice more than 500 kilometers off the surface. The energy also comes from tides. Enceladus is in a 2-to-1 orbital resonance with the other moon Dione. In other words, Enceladus revolves 2 times around Saturn for each revolution of Dione. These geysers come out of the region at the left, the far left of Enceladus here, where we actually find rifting occurring. It's the only other place in the solar system with active rifting. And it seems like warmer water from underneath is coming to the surface and then ejecting out. By the way, it's these tiny microscopic ice particles ejected from Enceladus's surface that are the source of one of Saturn's rings, the enormous E ring. However, it may be another one of Saturn's moons, Titan, its largest moon, that has the strangest surface of any of the planetary moons. And this is the last feature I will show you. These are the hydrocarbon lakes on Titan. These lakes are made of liquid methane and ethane. Now, there are a couple places on Earth where liquid hydrocarbons bubble up to the surface and exist as small lakes. The best known of these are the La Brea tar pits in Los Angeles. The largest are the La Brea Pitch Lake in Trinidad. Actually, was discovered by Sir Walter Raleigh. But the hydrocarbon lakes on Titan are huge, and there are many of them. The largest, Kraken Mare, named after the mythical sea monster, the Kraken, is 1,200 kilometers across. That's much larger than all of the Great Lakes combined. In fact, it contains many hundreds times the total oil and natural gas reserves on Earth. Liquid methane and ethane rain out of the cold atmosphere of Titan, and this liquid flows through networks of stream channels into the hydrocarbon lakes. By the way, it's the only other place in the solar system other than Earth where we see active streams occurring. And then we get to the topic of life. I would like to be able to say that there is some other place in the solar system where we will find life. We have a few possible candidates, but no confirmations yet. There's methane coming out of regions of Mars. Methane on Earth is often created by biologic activity. There are saltwater oceans on the moons of Europa, Enceladus, and Ganymede. NASA probes will continue to look for life, and when and if life on another planet is found, maybe in your lifetime, it will be the greatest scientific discovery of this century, or maybe ever. You know, it's fun to look at all the strange features within our solar system. In only a half hour, I've really just scratched the surface here. There's so much more. But remember, these are the planets of just one star. There are hundreds of billions of stars in just our Milky Way galaxy alone. And there are hundreds of billions of galaxies in the universe. That's a lot of stars and a lot of planets. We can't even conceive at this point of the other kinds of geologic features that might possibly exist on these planets. But we're trying. The Kepler satellite has a telescope that is focused on one spot of the sky near the constellation Cygnus. That's looking at 145,000 stars to try to identify any planets they might have. As of the year 2013, NASA scientists had identified over 2,000 planets around other stars that might be at the right distance from the star to be able to support life. We call that the habitable zone. Over 200 of these candidates are roughly Earth-sized. Now, it would be a long time before we could send a probe to one of these and hear back, many thousands of years at best. But humans have been around for over 200,000 years, so what's a few more? It wasn't so long ago that Homo sapiens had other intelligent species, like the Neanderthals, as neighbors. Maybe it will happen again. It might be impossible for us to ever get to those planets and see what geologic wonders their planets have. But maybe they will send us pictures and they'll tell us. Until then, there's no shortage of amazing geologic wonders down here on our own planet. I urge you to get out and see them. You know, I've tried my best here with words and pictures to describe some of the many different features of the Earth. But I hope you get a chance to get out, travel, and visit as many of them as you can. Thank you. Goodbye.